know the price of an object with tax, or maybe the price with tip. We know what the percent of the tax or tip is, but you don't know what the original price of the object is. In this video, we're going to show you how you can solve that kind of a problem step by step. We're also going to have a few examples for you and a few problems that you can try yourself and kind of check your work on. So that's coming up next on the Land of Math. So what we're looking at is trying to find the original price of an item when we know the tax or the tip, the total with tax or tip. So what we want to look at first is how do we actually find the total cost with tax or tip. So let's say we had a $60 jacket, and let's say there was 10% tax. The first thing we probably want to do is find out, well, how much do we have to pay in tax? So we take the $60 jacket, we'd multiply it by 10%, which we're going to write as a decimal, and we get $6. That's the amount of tax. We would then take the cost of the jacket, $60, add the tax, $6, and we get $66. That's our total cost with tax. Now, in this video, we're focused on finding the price of the original. So what is the original price? So let's say the question was this. If you have a $66 jacket with tax and the tax was 10%, how do you find the original amount? Now, this is the number one wrong way people do it. They take the $66 and they multiply by 10% and they get $660. But when they take the $66 and subtract the $660, they get $59.40. But we already know the jacket was $60. When we did our math, we should have come up with 60, not $59.40. So what exactly happened here? When we look back on the original problem that we did here, we took the whole amount, which was $60, and we added 10% of the $60. That was the tax, and that gave us our total cost. So when we kind of break this down a little bit, the $60 represents the whole amount. And we added that to 10% of the whole amount. Now we could use a variable like W to represent whole amount. If we combine the whole amount and the 10%, it would be 1.1. The W would kind of represent 1. So we know that if we took the $60 and multiplied it by 1.1, that should give us our answer. So if we actually take 60 times 1.1 on our calculator, you can see we get 66. And that was the cost that we came up with tax, just like you can see right here. So if we know that, what we can do is we can take the $66, we can divide it by this 1.1, which is the combination of the whole amount and the 10% of the whole amount. And we do that, we get 60. The $60, according to this, would be the whole amount, or the price of like the original amount. All right, so maybe you're looking at this problem and you're still kind of unsure of where we're getting this 1.1 from. So we know we take 60 times 1.1 and we're getting 66, but why? If we take 60 times 1, that would give us our whole amount. If we take 60 times 0.1, that gives us the $6, which is the amount of tax. If we take this 60 and we combine the 1 and the 0.1, we get 1.1. And when we do that, it's just like us combining the 60 and the 6 and getting 66, which is our total cost. Now, what we might want to do is think of this sort of as an equation. So we're going to make the W be our variable and represent the whole amount. So what we're doing is we're taking 1W, the whole amount, plus 0.1W, and that's going to equal T, or our total. So we're taking 1W plus 0.1W, and in this problem equals 66. Then what we're going to do is we're going to combine our like terms. So we have the 1W and the 0.1, so we combine those like terms, and we get 1.1W equals 66. Our goal here is to, now this is going to be a one-step equation. Our goal here, because this is a one-step equation, is isolate our variable, our W. And what we're going to do is divide by 1.1, and that leaves the W by itself. On the right side, we take 66, we divide it by 1.1, and we get 60. So in this one, you can see the importance of combining like terms. In our next example, example number 2, we're going to look at a $40 item. So that's the cost of this item is $40, and there's going to be 8% tax on this item. So we want to find the cost with tax. So we take our $40, which is the cost of the item, plus 8% of 40. And that's going to give us our total cost with tax. So we have to find out what is 8% of 40. So we'll go 40 times 0.08, and that gives us 3.2 or $3.20. So we take our $40 plus the $3.20, and that's going to give us $43.20. So if we want to find the original amount, let's say the problem was, what's the original amount of $43.20 with 8% tax? We would use 1.08, and that 0.08 is the 8%, times W equals 43.20, and we're just going to divide both sides by 1.08. On the left side, we get rid of the 1.08, and we just have our variable. On the right side, when I go 43.20 divided by 1.08, we're going to end up with W equals 40. All right, so we have 4 practice problems coming up here. The first two I solve with equations. The last two I solve kind of a shortcut method. So you can see here, we have a $29.21 cost with tax, and we know it's 15% tax. So we're going to use 1.15, and the 0.15 is the percent. W equals 29.21. I divide both sides by 1.15. When I do that, I'm going to end up with W on the left side equals, and if we take our 29.21 divided by 1.15, we end up with $25.40. So that was the original cost of this item before tax. If we look at the next one, you can see we're using 1.25 W. The 0.25, of course, represents the 25%. It equals the $37.75, so we divide both sides by 1.25. Again, the 1.25s will kind of cancel each other out, and we're left with W equals $30.20. The last couple here, these are just some shortcuts. I take the total cost with tax, and I'm just going to divide it by the 1.17. And when I take $327.60 divided by 1.17, I get $280. So the cost was $280 before tax. Same on the last one. I take the total cost, I'm going to divide it by the 1.8, which represents that 80%, and I get 76. So hopefully this video was helpful. Give it a thumbs up, subscribe, that would be swell. And until next time, we'll see you on the Land of Math.